Welcome back. So today again we are continuing with the sample paper solutions. So today I have selected some of the very important questions asked in the previous NDA exam. So all the questions what we are going to do today, they have selected from previous papers of National Defense Academy exam, that is NDA exam. So here is your first questions. What is the first question? The first question is, a sphere of radius r is inscribed in a cube. Find the volume enclosed between the cube and the sphere. Understand the question very clearly. A sphere of radius r is inscribed in a cube. There is a cube in which you are placing a sphere, and you need to find out the volume between the sphere and the cube. Okay, so let us go with like this. Let us see how we can draw this information in the form of a figure. So here we have a cube. So cube, when you see from the front, it looks like a square. And inside the cube, you are inscribing a sphere. So inside it, there is a sphere. So the cube will be like this. It's a three-dimensional figure. Now inside it, you have a sphere. And the radius of the sphere is given to you, r. So radius is r. So what will be the diameter? The diameter will be one more r here. So 2r. Because radius is given to you r. So diameter will be 2r. When you inscribe a sphere inside a cube, the diameter of the sphere will be equal to the edge of the cube. So this side you can take as 2r. These are the informations we get from the question. So when you practice these type of questions, more and more questions when you practice, it becomes easy for you. Then you will take only a few seconds to solve such questions. Okay, so the important part is understand the concept and take more and more questions like this and practice. 3 or 4 questions when you do like this, it becomes easy. Then after that, you will be taking only a few seconds to solve these type of questions. Speed and accuracy, that is very important when you prepare for your competitive exams. Okay, so we have edge here 2r and we have radius here r. We need to find out the volume between the cube and the sphere. To find the volume between the cube and the sphere, what we need to do is find the volume of the cube, find the volume of the sphere, subtract. So here we have the volume of the cube, volume of cube minus volume of sphere. This is the formula we have to use here. So volume of cube is, we have a cube, that is edge cube, and volume of sphere 4 by 3 pi r cube. So a cube, that is 2r is the side. So 2r cube minus 4 by 3 pi r cube. So 2 cube will become 8 cube minus 4 by 3 pi r cube. R cube is common here, so you can take that r cube common. So what is left? 8 minus 4 by 3 pi. So this is the correct answer. So accordingly, you can mark the correct option. So what you need to do here is understand the concept very clearly, what is given in the question, accordingly proceed. Okay, these are the questions asked in the previous NDA exam. So students preparing for NDA, it will be very helpful for them. Okay, so let us go to the next question. Here is your next question. What's the question? The total surface area of a cube is 216 square centimeter. Find the length of the longest pole that can be kept inside the cube. So here again the question is about a cube, and total surface area of the cube is given to you 216 square centimeter. So first we should understand what is the total surface area of a cube. So when we talk about the total surface area of a cube, students, we have a cube like this, which is having 6 sides. Side 1, back side 2, this side 3, opposite side 4, top and bottom 5 and 6. And each side is a square. Each side is a square. So if one side, one edge is equal to A, the one area will be equal to what? A square. One area will be equal to A square. Like that, how many sides are there? 6 sides are there. So what will be the total surface area of the cube? Total surface area will be equal to 6A square, where A is one side. So this is given in the question. What? 216 is the total surface area of the cube. That means you can take 6a square is equal to 216. From here, I can cut this 6 and 216. How many times? 36 times. So I got a square is equal to 36. Therefore, I got a is equal to 6, root of 36. A square 36. So a will be root of 36, 6. Very simple. Total surface area is given to you 216. We know total surface area of the cube will be 6a square. Why? Because one side, the area of one side of a cube is a square. There are 6 sides for a cube and 4 lateral side, 1 top and 1 bottom. 6a square is equal to 216. That means you can cancel the 6 and 216. You will get a square equal to 36. So from that we get a equal to 6. So one edge equal to 6. So a equal to 6. Now here you can use a shortcut method. What is the shortcut method? If you know the side of the edge of the cube, then the longest pole that can be kept inside will be equal to side into root 3. That is side into root 3. So here we got side is equal to 6. So the correct answer will be 6 root 3. This is a shortcut method. This is a shortcut method. Otherwise, how we will do? Starting from this corner. So this is your cube. Suppose this is your cube. And starting from this corner and back side top corner. Starting from the front side bottom corner to back side top corner. This is the longest pole you can kept. So how will you find out the height of this pole? Using Pythagoras theorem. Here you have a height 6. Here you have 6, one height 6. This diagonal when you take it becomes 6 root 2. And 6 root 2 and 6 when you using Pythagoras theorem, when you do the hypotenuse of this right angled triangle, it becomes 6 root 3. So this method is a long method. You need not to go for this method. This is the original calculations we need to do. When you calculate the longest pole length, the application of Pythagoras theorem comes here. But for competitive exams, we need not to do it. The shortcut method what we use is side multiplied by root 3 will be the longest side. So side we have already found out 6. 6 multiplied by root 3, 6 root 3 is the correct answer. So accordingly you can mark the correct option. Okay. So let us go to the next question. So here is your next question. So what is the question? The question is, find the number of solid steel balls of radius 2 centimeter that can be made by melting a sphere of radius 8 centimeter. So what are we doing here? We are having a sphere of radius 8 centimeter, a big radius. We want to melt it and we want to make small spheres of radius 2 centimeters. So how many balls, how many steel balls you can make out of that big ball? So what actually the question says, you have a big sphere having a radius 8 centimeter. You have to melt it. You have to melt it. After melting, you are making small balls of radius 2 centimeter. Of radius 2 centimeter. The question is, how many such balls you can make? The very important concept you have to understand here is, when you melt and convert, the volume of the total sphere will not change. The volume will not change. Suppose the big sphere have some volume V, even after melting, the shape changes, the state changes, but the volume will not change. So the volume remains constant. So using that concept, I can tell you the volume of this sphere will be equal to volume of all these spheres. So now you can find out how many balls will be there. That is, number of balls will be equal to volume of the big sphere divided by volume of the small sphere. So number of balls, that is what we need to find out. So number of balls equal to volume of big ball, that is big sphere, divided by volume of small sphere, small ball, sphere or ball, whatever it is. So volume of big is what? sphere volume 4 by 3 pi r cube. R is 8 here. So 8 cube. Divided by volume of small sphere 4 by 3 pi 2 cube. Here 8 cube. 4 by 3 pi r cube. That is the volume of a sphere. Here 4 by 3 pi and 4 by 3 pi you can cancel. So this becomes what? 8 cube means 8 into 8 into 8 divided by 2 cube. 2 into 2 into 2. So 2 into 2, 4, 4 into 2, 8. 1 8 and this 2, 2, 2 cancel. Remaining is 8 into 8. So what is 8 into 8? 64. So how many balls we can make out of this big ball? 64 big balls we can make. So accordingly you can mark the correct option. So this way, the main concept we have to understand here is whenever you convert a sphere into any other shape, the surface area may increase, the state may increase or decrease or it change, but the volume remains constant. The volume will be same. Using that concept, we have to calculate the number of balls here. Kindly note it. Okay, so with more and more questions, we'll be meeting in the next video. So if you are watching this channel first time, I request you kindly subscribe and don't forget to press the bell button. Okay, so that whenever I upload new videos, the notification will definitely come to you. Okay, so take care, prepare well for your exam. Take care and bye-bye.